Okay, so this is CSEC Math 2025, paper 2. So now let's do question 2. So they're saying to factorize completely each of the following expressions, and then they have the first one is xy squared minus x squared y. And as we know, the main thing to do here is to look for common terms in each bit of it and pull it out, and then make it like a product. So in this case, we have xy is common in both terms. So when we pull it out, we'll get xy into, and then what's left here would just be a y. So into y minus, and then what's left here would be an x. xy into y minus x. And just to double check it, what you could do is expand it back out. So we got this is our answer, xy into y minus x. When we multiply it back out, we'll get xy times y, which is xy squared, and then we have xy times minus x, which is minus x squared y, and that's the same thing. So we could just double check that, after we factorized it, it is the same exact expression. So now moving on to part 2, they have 3x squared plus x minus 10. So the first thing to recognize here is that this is a quadratic. So in a quadratic, it's of the form ax squared plus bx plus c, right? So that's ax squared plus bx plus c. So in this case, if we match it all up, we'll see that a is 3, b is the coefficient of the x term, so that's 1, b is 1, and then c is this term here, so that'll be minus 10. C equals minus 10. So when we're factorizing a quadratic, the first thing we do is we check what is the product of a and c. So step 1, what is the product of a and c? ac equals 3 by minus 10, which equals minus 30. Okay, great. Step 2 is we want to figure out which two numbers, when we multiply them, will give us AC, but when we add them, they'll give us back B. This is just how we do it, right? So in this case, so we want to find two numbers that multiply to give AC and they add to give B. B is 1. So we could think about some possibilities, right? What are the numbers that we could multiply to get minus 30? So we could do 30 times 1, well, minus 30 times 1, or 1 times minus 30. Neither of those, if you add them, will give us B. So what you'll have to do is try out a bunch of factors, and in this case, what we'll get is 6, write it like this, 6 times minus 5 is what would work, because 6 times minus 5 gives us minus 30, right? So that'll give us our AC, and then 6 plus minus 5 gives us B, because B is 1, and 6 plus minus 5 is 6 minus 5, which is 1. So in this case, we're going to rewrite it now that we know the two numbers that satisfy these steps. So let's write it back. So instead, we'll now get 3x squared plus 6x minus 5x minus 10. Okay? And if you look, this is the same thing because 6x minus 5x, that's just x. So this is the same expression as this, but these are the steps that we typically follow when we're trying to factorize a quadratic. So the next thing we'll do is we're going to look for, like terms to pull out. So we're going to group it into two groups. So the first group we'll have is these two, and then these two. So looking at the first group, we could pull out 3x, because 3x is common to both terms. So if we pull it out, we're going to get, this first term becomes 3x into x plus 2. And what you should always do when you factorize is just to double check. You could just multiply it back out. So if you were to multiply it back out, you get 3x times x, which gives us 3x squared, and then 3x times 2, which gives us 6x. So this is the same, so that is correct. The second bit, we could pull out minus 5. That's common to both. So we'll get minus 5. Let me write this back. Minus 5 into, if you take minus 5 out of here, you get x. And if you take minus 5 out of this one, you get 2. And you could double check again by multiplying it back out. So minus 5 times x will give you minus 5x. And then minus 5 times 2 will give you minus 10. Right? So this is the new expression we have for now. 3x multiplied by x plus 2 minus 5 multiplied by x plus 2. And then, so this is one term now, this is the other term. And as we can see, we have something common again, which is the x plus 2. So we're going to pull it out. So we get x plus 2. And when you take it out of this first term, you'll be left with 3x. When you take it out of the second term, you'll be left with minus 5. So, and just to double check, you could always multiply it back out, and you'll see you end up back with the same thing. So these are the steps we typically follow when we're factorizing a quadratic. And if you found this was a bit tricky to follow, then you should probably do some more practice with factorizing quadratics, because it's typically like these steps to follow and you have to be kind of familiar with it. Otherwise it might get kind of confusing. So if you found this was a bit difficult to follow along, then I would recommend doing some practice with just taking some quadratics and factorizing them. Okay, so for part B, this is solve for n. And the equation is 4 to the power of n divided by 4 to the power of 3 is equal to 1 over 4. So we could write this back as 4 to the power of n over 4 to the power of 3 is equal to 1 over 4. And we want to kind of get rid of the denominator here. That might simplify things a bit. So we could multiply both sides by 4 to the power of 3. So do that on both sides. So this will cancel over here. And so this will become just 4 to the power of n is equal to, and on this side, on the right side, it'll become 4 to the power of 3 over 4. And, well, however you want to think about this, you could use the rules of indices, or just recognize that 4 to the power of 3 is 4 by 4 by 4. So 4 to the power of 3 divided by 4 would be just 4 by 4. So 4 to the n, this will simplify to 4 squared. And now we have 4 to the power of something is equal to 4 to the power of 2. So just thinking about it, you know, n would have to be 2, because in order for this equality to hold, the only way it's equal is if this and this is the same, 4 raised to the power of both things being the same. So in this case, n equals 2. That's the answer. Okay, and so for part C, they say the lengths of 3 sides of a trapezium are shown in the diagram below. The area of the trapezium is 750 square units. So they ask you to write down an expression in terms of P and Q for the area of the trapezium. So first of all, the formula for the area of a trapezium, area is equal to 1/2 times the sum of the parallel sides times the distance between them, right? So in this case, that would be this. These would be the 2 parallel sides, and this is the distance between them, right? So in this case, the area is 1/2 times the sum of the parallel sides is the sum of this side and this side. So that's 1/2 times 4p, that's one side, and 3q is the other side, multiplied by the distance between them, which is 6p, right? And then you could even simplify it, because you could just like, it's this times this times this. So that'll be 3p, because a half times 6p would give you 3p, multiplied by 4p plus 3q. And then you can even expand it more if you want, and put 12p squared plus 9pq, but it doesn't really matter anyway, it's fine. They're all the same. So that's the expression in terms of p and q for the area of the trapezium. Then the next question says, given that q equals 2p, determine the value of p. So we already know from what we just found out that the area is 12p squared plus 9pq. And in the top, they say that the area is 750 units squared. So we know that A equals 750. And they're saying here also that Q equals 2p, right? Q equals 2p. So now, with that information, in order to solve for p, we need to get rid of everything except p. That should be the only variable left in our equation. So we're going to make two substitutions. So we're going to write this back. A, but instead of A, we put 750 equals 12p squared plus 9p multiplied by, and now we're substituting q because q equals 2p. 2p. Right, so we could write this back out. 750 equals 12p squared plus, and then 9p by 2p is 18p squared, right? Then we have some like terms, so we're going to group them. So 750 is equal to 12p squared plus 18p squared is 30p squared, right? And now we want to solve for p, so we have to start getting steps to make p the subject of the formula. So we could divide both sides by 30. Divide this side by 30, divide this side by 30, and we'll get p squared is equal to, well, let me write it the other way. So this divided by 30, this side divided by 30, we get 25 is equal to p squared when you divide both sides by 30. And if 25 is equal to p squared, take the square root of both sides. So then p is equal to be the square root of 25, which is 5. So the answer is p equals 5.